Okay, so researcher number 8. Researcher studies water clarity, repeats it on the same dates 5 years later, immerses a disk, and see how long he can seize it. So this is the lake, and the researcher is there in a boat and has some kind of a disk on a string that's black and white. He's dropping it in the water and is trying to figure out how deep the researcher can go and still see the disk. So deeper means clearer. Right? The deeper you can see into the water, the clearer it must be. So he did some measurements on January 25th, on March 19th, on May 30th, etc. If I take a look at this, it seems like the clearest water is in March. So March is clearer than May. So it makes a lot of sense to do it on the same days. Doesn't make sense to compare March of one year to May with another year. Right? It only makes sense to compare March with March, May with May. So exactly, Thomas, this is matched. Okay, in this case, when we look at the numbers, it's pretty obvious it should be matched. November is low, so it's not useful to compare November to March because March will be higher in any year. It only makes sense to compare apples with apples, November 7th, November 7th. So why is it important to take measurements on the same date? It makes the second dependent on the first. Not that it's easier to remember. It doesn't maximize the difference. We want to match them as well as we can. Okay, continue. Does the evidence suggest that the clarity is improving? Okay, so let's go. We could either take the difference and use a one sample test, or we can use StatCrunch. So let's click this box, open in StatCrunch. I have to use my other mouse because I have to go to my other screen. Okay, so here are the data. Stat. It's two means, so it's t-stats. All of our studies on means use the t-distribution. You see one sample, two sample is independent. We have matched pairs. Sample 1 is in initial. Sample 2 is after 5 years. Hypothesis test. The null hypothesis is that the difference is 0. Does the evidence suggest that the clarity is improving? So the alternative is more clear, which means that the 5-year measurement should be more than the initial. Right? More clear means can see further. So our initial was the first mean. This is how we listed it. So that's mu1 minus mu2 is negative. The distance has increased, so the difference is negative. Okay, so we have to find StatCrunch. Okay, so the difference is negative because mu2, which is the after 5 years, is bigger. Thanks, Nadine. I guess you're, if Brian's not here, you're taking over his role. Okay, so here it is. The t-statistic, the test statistic, the p-value, alpha equals 0.5, p equals 0.3. So we have alpha equals 0.5. And from what we just did in StatCrunch, we have P equals 0.3. So is this a reject or do not reject? Exactly, the null must go. P is low. P is lower than alpha, so it's a reject. Okay, so far so good. We need to figure out, what does reject mean? Whoops. That's it. Okay, so let me ask you, what does reject mean? Is the water getting clear? Yes or no? Okay, so this is important to get the last step. Reject means we believe the alternative hypothesis. The alternative hypothesis is that it's getting clearer, so our conclusion is that yes, the water is getting clearer. The null hypothesis is that it's the same, in other words, equals. The alternative is that it's getting clearer. We rejected the null, which means we believe the alternative. It is getting clearer. Okay, so this is important to not just get the reject and do not reject, but be able to relate it to the original statement. I think a bunch of the other problems do that. This one is shorter.